Good morning. I just want to say that first, I'm not a professional electronics engineer. My career is really on programming, designing cloud applications, and work with Python. But I have a passion for learning and teaching, especially a small attraction to electronic devices. So when I started studying, I started in electronics engineering. But after 2 years, my wife told me, everything we're doing in the university is related to computer science, so I changed my course back to computer science. I never finished electronics in the university, but the passion continued, and now I can come back and play around with these beautiful devices that I try to make it easier to attract new people to programming and also playing with circuits. So I will share my experience with this device, the Raspberry Pico W. Okay, so a bit about me. I wrote a book in 2010 that was very well received in Brazil, and I just translated it to English. This is one of the reasons why I didn't advance so much in the project, because I was reviewing this book. I have a little company in Belgium, so I'm Brazilian, but I live since a long time ago in Belgium, almost 20 years now. I worked with European projects, research. Usually I work with distributed systems and parallel programming. Okay? So why did I try to do this? Why playing with the MicroPython, Raspberry Pi Pico W, and this kind of stuff? When I started to teach and interact with people, it's very difficult to attract the attention of all students. Some students will just care about what you are talking, they will follow the course, they will get good grades, and everything is fine. But you will always miss somebody, because they want something more concrete, they want to touch, they want to play with something, or they want to build something at the end of the course to motivate them during the learning. And I think using a hardware device is something that attracts especially younger students, because they can touch, they can play. And if you use devices like the Raspberry Pi Pico W, you can even move around. For example, use an external battery as a power supply. Using the Wi-Fi, you can make it more interactive and access it remotely, so it does not need to be tied to your computer. So I found it very interesting and not very expensive, as we'll see. So the idea is to make learning electronics and Python more interesting, very simple, affordable, and engaging. So I didn't want to build anything that would break the bank. Initially, my target was 10 euros. When I checked in April, it was feasible. I updated the prices 2 days ago. It's a little bit more expensive. Now it's 13 something. So I set a new goal of 15 as more realistic. And you'll see the bill of materials in another slide. Okay? So the main idea is to play with simple devices like buttons, the LEDs, the Raspberry Pi Pico, attach a display, and help the students to learn by doing, understanding what they're doing, and have this kind of visual feedback, because it's very nice. Even a LED blinking in the beginning is very attractive, because hey, I'm controlling an external device. What does it happen if I put 2 LEDs, 3 LEDs, if I change the colors of the LEDs, and so on? So this may attract a different population than if you are just displaying lines with print in the console. So as I said, it's a different way trying to attract more people to programming and electronics, why not? So we need to buy some hardware to make it work. I try to keep it very, very cheap. So I'm using standard LEDs, standard button switch, and wiring that are very, very common. The most expensive part is the Raspberry Pi Pico itself. But it's not super expensive, as you can see. Raspberry Pi Pico W, I checked the price in the Netherlands, because this is where I source my devices. in the Raspberry Pi store. And the kit with a Raspberry Pi Pico with headers, soldered headers, and a USB cable to connect to your computer was about €8.95. So it's not super expensive. It's something affordable, I think. The breadboard depends a lot on the quality of the breadboard and where you are going to buy it. The cheapest ones are on China, so probably you have to source them using Temu if you want to have something cheaper. The LEDs, wires, push buttons, and resistors, more or less €2 if you buy them in a bundle. If you go to Amazon, you find lots of products where you can buy, for example, 5 LEDs, 5 resistors, but they are very, very expensive. So if you don't pay attention, you pay €5 just for the LEDs. So try to buy a bundle where you have the LEDs, the wires, and the resistors in a single pack. They are very common in these Chinese shops like Temu. And so you can get them more or less for €2. And I would like to have a display. So the cheapest I found was this SSD 1306. It's not very big, so it's about it's a little bit less than 1 inch, and it's 128 by 64 dots. And in the first line, the first 8 lines, you have a yellow color, and in the bottom, you have it on blue. So you can play it a little bit with 2 display areas to show different things on screen. But it's very cheap, €1.20. If you buy them in a pack of 5, sometimes you can even get for less than €1. And I think this is not very expensive if you have, for example, to have a class where you need 5 or 10 kits like this. You can very well source the materials and reuse, because the chances that you break or damage this device is not very high. The easiest thing is to burn the LEDs, but they are very inexpensive if you buy them in a kit. Okay, so how to make this accessible to new Python programmers or people that want to program with Python? As we have seen in the other presentations, MicroPython is a very good alternative for this, so I decided to use it. It has a REPL on serial ports, so usually this is Visual Studio Code. The Raspberry Pi, once you install MicroPython, you have a serial connection through the USB cable, and you can use it like any standard Python interpreter. You can import, you can turn the LEDs on and off, and just using the simple command line. Of course, as soon as you start using the IDE, you can upload source code, run source code, stop it, and this work is very, very simple. With MicroPython, you also have a tool called MIP that works like pip and help you to install external modules into the microcontroller. So for example, if you want to use microdot, micro requests, and external code, you just do something like MIP install and the name of the module. So it's quite handy. And another advantage of MicroPython is that it's compatible with multiple boards, so you are not tired to use the Pico W. But of course, it's one of the less expensive, and it's quite powerful. The second version of the Pico has the 2 times more RAM, and yeah, you can run almost anything on it. Also, in MicroPython, you have to play a lot of async programming, so this is the hardest part, I think, but it's doable. So I prepared a set of experiments that use these components. I'm still documenting them, especially trying to draw everything in using Fritzing. It's a tool where you can have a graphical display of what you are trying to build. You can also simulate the design before you build, and you can almost automatically get a schematic view of the assembly. So I'm starting little by little to draw then on Fritzling, put on GitHub so people can also download the designs and try to build them. And it's part of the project to add more documentation, especially instructions on how to assemble these experiments. So very simple. As usually, we start connecting a LED, making the LED blink, adding button to turn the LED on and off, and then you start connecting to the MicroPython, installing MicroPython to the Pico, and you change. Now you start controlling the LED with MicroPython, which is very, very easy, requires very few lines of code. And the challenges start when you have to connect to the Wi-Fi. It's not so easy, but I'm providing a few lines of code that will load the Wi-Fi configuration from a JSON file, try to connect, and if it does not connect, you have a clear error message, what's happening, and this helps a lot. Most of the time, if the SSID is okay and the password is okay, it will connect in a few seconds, so you should not have any problems. I tried to make this work in the hotel, but as in the hotel they have a captive portal, I didn't have the URL to send my email to it, so I had to use my iPhone, and it's not the best setup. But if you have a standard Wi-Fi like we have here in the conference, it's quite easy to set it up. The second part of the experiments are serving a simple HTML page, controlling the LED on the mobile phone. The idea is if you can put a little web server in the microcontroller, and the microcontroller connects through Wi-Fi, you can very well use a mobile phone, open that home page, turn the LED on and off using buttons in HTML. Why not? We just seen in this room 2 presentations before mine that you can also use MicroPython. In these experiments, I started from a web server that I found in a blog post, and I started to add the features I didn't have. Probably in the future, I will just use MicroPython. But here on GitHub, you'll find a HTTP server PY that is a handmade async server just for this. The advantage is that you see everything, so you can change, you can play around, and I think it can be useful if you're learning. Okay, once the Wi-Fi and the web server were complete, I started playing with the SSD 1306. There is a hardware device, the little display, that uses SPI. So SPI is like a serial bus where you can put multiple devices. You need to wire 4 cables to make it work. And then in using MicroPython, you have a module that help you out regarding sending commands to the display. So the hardest part is to have the wiring okay. And I created a small program, for example, to detect the device in the SPI bus. So I will, after this, I will show the source code. Okay? Okay, so far we have the Wi-Fi connection, we have the little web server, we have the connection to the display. And then I thought, okay, but let's make something like a game. And to have a game, we can have buttons. I created a little pad with 3 buttons, one for the left, right, and one to fire. And added a few codes, for example, to enable sprites and collision detection, just to make a game like a small Space Invaders. I'm sure that the students, as soon as they start working with this, they will have many more ideas of what they want to do. And I would also like to share some of the experience. So this is the Pico. It's really, really small. It's something like this. The version I'm using has Wi-Fi, but when I was debugging the display, for example, I didn't need this, so I had another one that is cheaper, and I knew that I could burn or break, and I started playing first with it. The main challenge, and a mistake that I did, was that I got the board without the headers. So the headers are these little pins, and usually the Pico is sold without any of them. So you need to buy the headers and solder them one by one. Okay. So as I had no idea how to solder, you can see how beautiful it became. So my advice, if you buy one of these, you never solder in your life, buy with the headers. Okay, usually in the shops you have one without the headers and another one with the headers. It's €1 more. It's included in the kit that I'm proposing. And once you have the headers on, you can use a breakout like this, or you can plug it directly into the breadboard. And then it's much easier to play around. Then after this, you don't need to solder anything. Okay, this is the setup of the display. So as I said, the wiring is a little bit more complex. That's why I want to draw it in the beautiful program so you can have the schematics, because just by looking, it's really hard. But I will add more pictures into the documentation. And this is more or less the final setup, where I have the little pad with the 3 buttons. Okay, so I try to wire it in a way that the wires would not hide the buttons. So, and the breakout board that you don't need, but it's very helpful if you can have one, and the display at the top. And this is the little Space Invader games that started to run. It's basic. It's Space Invaders. You fire, you kill the enemies. If you reach if you kill all of them, it displays game over. This is all it does. Okay. So if you want to find the source code, I put it already on GitHub. I have to enhance the documentation a lot. So if you are interested into it, bear with me. I will keep enhancing it. You can contact me in this email, and in most social networks, I'm at LSKBR, so it's easy to contact me if you need. As we still have some time, I would like to change to the code. Okay, so this is an example. Tell me if it's not too small. So this is an example of how to turn the LED on and off. Okay. All this is on GitHub, so I'm just showing some of the code. This is the web server part that I said. This is more complex, but I think you don't need to fully understand how the HTTP server works unless you really want, but it's a very raw web server that I took from a blog post and extended it. So only if you really need to understand how HTTP works and this kind of thing. Otherwise, you can go directly to the program that uses it. So this is the wcon.py example, where you have, where you have the Wi-Fi config. As I said, it's simply as loading a JSON file with specific fields. You do some testing regarding errors. I also did some functions to translate the error messages in something that I could process, although before I was just printing the numbers. This is the LED that we can control using the web server, so, and now the code that goes around it. Okay, so the code is not extremely complex. It just takes some time to get together this, plus all the wirings on and all the hardware setups, especially if you are a beginner. But it's not extremely complex. It's something that in one weekend, I think you can assemble everything. Okay. So I also use NTP to synchronize the time, because the board has a real-time clock. But of course, when you remove the power, it does not save the time. And sometimes you need, especially to know if you get the good home page, if the time is okay. Okay, so I print the date and time, and then I start here the web server. And it's very simple. As you can see, the HTML page that I read in the web server is simple text in the middle of the Python file, so you are free to change, rerun, and tweak about this. So it simply reports the status of the LED. It has 2 buttons that leads to an API that can turn it on and turn it off. So it's super simple. You can also have programmatic access to turn it on and off if you need to. But the idea is to give an example, and then the user or the teacher can extend this to say, okay, now I will get, for example, the score of the game using the web server, or design other simple things. The main loop is not very complex neither, so I'm just checking here the status of the LED. I check if it changed, and I print. Okay, and this is the part that I think it's the most async part, is where I create the async task that will run the server, the main loop, and that's it. Okay, these are some lines with MIP that I have to clean up. This is the I2C scanner, so if you are trying to plug for the first time the display, you will need something to tell you if it's in the bus, and you need to know the ID of the device. So the code tries to find the device, and it will display all devices it found. Okay, so it's easier. I used it a lot when I was first wiring the device. It's not so difficult to plug it in the wrong way. And finally, we have the game. So I instead of using images, I said, okay, let's do it old school. So let's draw using ASCII characters where each X is a dot. As the display has a single color, each X is converted to the binary 1, and all other characters are 0. So it's quite easy to see. So here you have the player and the rocket that I tried my best to draw. And the code that converts this into the binary representation we need. So this is a little bit tricky, but it's a function. You can just use it unless you really want to get into little details about that. Collision detection, because if you have sprites, you want them to detect collisions, right? And a very simple sprite class where you have X, Y, how large and how high is the sprite, the code that calls the collision detection, and that's it. Okay. The universe is the base for the game, so this is where you put all your sprites, so you can add sprites that will be drawn on every frame, and also update the status. For example, if you want to move the sprites, you can do this. You can co-update. And the invaders is the simple game, so I extend the universe, and now I can add the player, the enemy, and the rocket, each of these in a different method. I also have some code here to move the rocket, because the rocket needs to move up to have the game. I check the hits. Of course, if it collides, I print boom in the console because I don't have a speaker. So it's just a print, and I remove the enemy and the rockets that collided from the lists, and that's it, okay? And in the end of the game, I just check. If I don't have any more enemies, the game is over. So it's a very simple game. I think it's easy to tweak, add more enemies, move the enemies differently. For example, make the enemies also fire something. Just pay attention that if you add many objects, it starts to get slow. Okay, there is a price to use classes and all this stuff in a microcontroller, so we always need to pay attention to the limitations of it. Okay, so this is the initialization of the game, where I create 2 rows of enemies, the player itself, the initialization of the display, so you just need these 2 lines. I initialize the game, the 3 buttons that I have to read to have this small pad working, and the main game loop is just this. Okay, so you draw the current status of the game, you try to move the enemies to the right and to the left, like in the old Space Invaders game, because they have to move, otherwise it's too easy to shoot. And then I check the buttons. You see lots of prints here, because when you are trying to wire this, it's good to have a feedback if the buttons are working and if you are pressing the right button. So I put the print, but they are not necessary. And depending, for example, if I click the left button, it will simply decrement the X position of the player, so it will move left. On the right, it will do the opposite. I check the bounds, so it will not go outside the screen. And the same thing for the rocket. When I press the middle button, it simply creates a new sprite and start making it, put it just on top of the player, and then the engine will move it up until it gets until it hits an enemy or until it goes outside the screen. Okay? So, and that's it. So I check for the end of the game. If the game ends, I break the loop, and that's it. It can run barely at 10 frames per second, but it's fast enough to be fun, and it's something that you can tweak and change and check how it goes. I think the students may have some fun drawing different sprites and trying to implement different games. And as you can see, it's not very big. We have the full game in more or less 220 lines of code. So I think it's quite feasible to have this kind of activities in a class. Okay, you have all the source code on GitHub. The documentation is still pending. I try to put a README, but it's really the basics of what you need to do, how to create the Wi-Fi JSON, and what each example program does, but it will get better over time, okay? And that's it, so let me back to Canvas.
So do you have any questions? So please raise your hand if you have any. Any questions?
Hello, thanks for the talk. Can you explain what is the bottleneck for the 10 frames seconds?
The display is connected to the device using the SPI. So when you need to draw a new frame, you need to send all the dots using the serial port. So there is the limitation of the speed of the serial port. So each line, you have 1 bit per dot, and you have 128 by 64. So it takes a little while. I think you can easily reach 15 frames, but if you do this, you need to simplify the logic of the game. Because the hardest part here, for example, is to visit each element in the list to search for the collision with the enemies. And if you are fighting a lot, because usually you keep fighting, we create lots of elements, and you need to check the collision with each of one. And this is something that can be improved, but would make the game much more complex. So I think as an initial version, it's good as it is, because it's very simple, but it can be optimized. And then we can get more frames. But it's in this kind of display, we will never have 30 frames per second. It's really designed for more static data. The game is already a stretch that we are doing. And for less than €1, I think it's a good display to start with. After that, there are much better displays that can be plugged to these devices. But the complexity to wire and to set the software to work with the displays is also much higher. That I thought the cost is prohibitive, because if you buy a little display, it easily starts at 20, 30 euros, and it can go up to 90 euros just for the display. And I said, okay, this is too fragile to have in a classroom. But this €1 display, even if they break, you just plug another one, and it's good. But it's low. Okay.
So do we have any more questions? Okay, so I think that's it. So thank you, Nilo, for your wonderful talk.
Yeah.
So please give him a round of applause.